Hello, today we are going to learn how to prove Gauss theorem. So first let us know what is Gauss theorem. So Gauss theorem states that the net electric flux passing through any closed surface is 1 by epsilon naught times the total charge Q present inside it. So what it is that? Like phi stands for net electric flux. What is electric flux? It is the number of electric lines, electric field lines passing through a point. Okay, so in the case of Gauss theorem, the net electric flux passing through any closed surface, we are talking about a closed surface in the case of Gauss theorem. So through a closed surface, how many electric field lines are passing? That is equal to 1 by epsilon naught into Q. What is epsilon naught? It is the permittivity of free space. What is permittivity of free space meaning? Permittivity of free space means that capability of vacuum to permit electric field. So, how much electric field can be permitted in a vacuum? That is epsilon naught. Now, this is the ratio between the permittivity in a medium and permittivity in free space. So, this K is a constant. So, if the medium is not vacuum, then we have to take not epsilon naught, we have to take epsilon. So epsilon is K epsilon naught. In the case of vacuum, K is equal to 1. So according to the medium, so here we have written 1 by epsilon naught because we are considering vacuum as the medium. But if it is something else, then we have to write 1 by epsilon. And what is epsilon? Epsilon is K epsilon naught. So now we are going to prove Gauss theorem. So for that, we are taking electric field E is equal to 1 by 4 pi epsilon naught Q by R square. This formula we all know very well. Now, there is a relation between electric flux and electric field. Of course, it will be there. So, electric flux d phi is equal to E dot ds. The arrow mark shows that both are vectors. There is a dot product. So, dot product naturally it will culminate as E ds cos theta. Dot product of two vectors, you get E ds cos theta. Okay, if it is A dot B, then it is AB cos theta. So a dot product always gives that way. Now, so we can see that 1 by 4 pi epsilon naught Q by R square. Okay, so electric flux d phi is equal to E dot ds, d phi is equal to E dot ds cos theta. We already said. Now we are talking about a closed surface. Gauss theorem is related with closed surface. So the surface integral, we can see this is surface integral notation. Surface integral of d phi is equal to E dot ds cos theta. Now when we are looking into it, we are considering a closed surface. Okay, so we are considering over here a closed surface of any shape, let it be. So we are considering a point P over here. A small area ds is considered. So ds is going like this, E is going like this, theta over here. But for you to understand, let me tell you that, see, E will be always perpendicular to the surface. Perpendicular to surface. And ds vector will also be perpendicular to the surface. So then what is the angle between E and ds? Theta will be equal to 0. I hope you are understanding. In that case, we get phi is equal to d phi is equal to E ds as cos 0 is equal to 1. I hope you all understood. Now when we are considering, like suppose we are considering a sphere over here. So in order to know that, first we are going to show you. how it is like. Now, integration of d phi is equal to 5. Now, 5 is equal to integration, close surface integration of E ds. Now, in this case, E is what? Phi is equal to, we are going to substitute the value of E, that is q by 4 pi epsilon naught r square ds. Now, if we are considering this as a sphere, so the ds area will be phi is equal to, we know that q is a constant, 4 pi epsilon naught is a constant. Okay, so inside the integral we will get r squared is a constant. Okay, now instead of ds we are getting the whole integration of ds as area A. So area of a sphere we are taking it as, surface area of a sphere we are taking it as q into 4 pi epsilon naught r squared into 4 pi r square. So now look, all the things 4 pi and 4 pi will get cut off, r square and r square will be cut off. We are coming into our equation, we are proving that, what we are proving finally, we are proving phi is equal to q upon epsilon naught. This way we can prove Gauss theorem. So that's it. Thank you.